Miss Collier explains.
The balance method.
Today, our learning intentions are to understand that we can find simpler equations by using opposite operations, to be able to solve 1- and 2-step equations algebraically, and to understand that equation solutions can be checked by using substitution into the original equation. We will know we are successful when we can solve 1- and 2-step equations algebraically, and then use our solution to substitute it in and check that we are correct. Today's lesson is a little bit different because it is brought to us by the greatest titan alive, that is our man Thanos. And he once said a very wise quote. Perfectly
balanced, as all things should be.
And this is what I want you to know. He may have been talking about calculus, but little one, I'm talking about algebra. Everything we do in algebra needs to remain balanced. And yesterday we learned about our scales, and we learned about keeping things balanced by doing the same thing to one side that we do to the other side. So today, as you go about trying to solve your equations, you need to make sure that every equation is staying perfectly balanced by doing the same thing to the left-hand side that you do to the right-hand side. And I will tell you, Thanos is watching. So make sure that you are keeping your equations perfectly balanced by doing the same thing to the left-hand side as we do to the right-hand side. And then we can solve any algebraic equation we want. In algebra, we really have to think about the order that things happen. Let's think about a soccer player. He might put on his shin pads, then his socks, then his shoes, play his game, and then at the end of the game, he undoes that in the opposite order. He's not going to take off his socks before he takes off his shoes. It's impossible. We have to do it backwards. Another way to think about it is like a shoelace. If I tie a knot in this shoelace, and then I tie another knot, and another knot, and I keep going, there is no way to undo this first knot unless I undo all of the previous ones first. I have to do it backwards and in order to undo what I've done. That is what we really need to remember when we are doing mathematics. We're going to follow the similar procedure when solving algebraic equations. We are going to do the process backwards in reverse. Let's look at an example. Here is an algebraic equation, x equals 3. Then keeping it very balanced, I have times by 2 on both sides to create an equivalent equation. Again, balanced, I've added 4 to both sides to end up with a third equivalent equations. All of these are equal to each other. So my steps were times by 2 plus 4. First I times by 2, then I added 4. But let's imagine that we were given this equation as our starting point, and we had to go backwards. We had to simplify. Well, in order to do that, in order to undo the first shoelace, I'd have to do the opposite of the last thing that we did. The last thing we did was plus 4. So now I need to take 4 first. If I take away that 4, this will disappear, and now I have an equivalent equation. Then the next part of the shoelace was times by 2, and I have to do the opposite, which is divide by 2. And now I've ended up with a solution, with the simplest of equivalent equations. All of these are still equivalent equations because I've used my balance method in order to ensure that I do the same on both sides. But now I have x all by itself, so I know the solution to this equation. But as you can tell, we had to do the opposite backwards. So we did times by 2 plus 4, and then we did take 4, divide by 2. So remember that solving an equation is finding the pronumeral that makes the equation true. And to solve an equation that we can't do via inspection, we have to find simpler equations using our balance method to form equivalent equations until the pronumeral is all by itself. So as I've said, to find the simpler equation, we can apply the opposite operation backwards. Thinking of the shoelace, what is the last thing they did? If the last thing they did was plus 4, then to undo it, I'm going to have to take 4. So we're thinking of it in order. The other good way to think about it is it's going to be the opposite of BOMDAS. It's going to be backwards BOMDAS. Because if to make the shoelace, they had to do addition and subtraction last, that means that's the first thing we're going to have to undo. So you really need to think in your head, what are the steps they took? And then figure out, how do I work that backwards? One of my absolute favorite parts of algebra is the ability to check that you've got the answer right immediately. We can literally figure out the answer and then we can do a check using substitution and we know instantly that we've got the question correct. Let me show you. And we always need to do this. So what we do is after we've done a question, which I'll show you in a bit, we write check. And then we write out LHS, which we know stands for left-hand side, and we write RHS, which stands for right-hand side. And then we write what's on each of those sides. So on this side, it is 2x plus 4, and on this side, it is 10. Then I take my answer that I think the answer is, which x equals 3, and I substitute it back into my original equation. So I'm going to go 2 times 3 plus 4. And then I solve. 2 times 3 is 6. 6 plus 4 is 10. And then I look, is my left-hand side equal to my right-hand side? My left-hand side is equal to 10. My right-hand side is equal to 10. Therefore, I've ticked it. They are equal to each other. And I'm going to put my 3 dots, which remember mean therefore x equals 3. But that means that when I'm doing my work and I think, okay, this is what I think the solution is, I can check straight away. And that way, if I get it wrong, I can go, oh, okay, I need to try again. Maybe I undid the wrong part of the shoelace at the wrong time. Also to note, if you get it wrong, do not rub that out, all right? Do not rub it out. Draw a line or even write, therefore, x, if I'd been wrong, I could have written, therefore, x does not equal 3. And I could have written that. And do you know what that does? That tells my teacher that first of all, I'm checking my own work, and also that I understand the process. And once I get something wrong, I'm going to go out and try to find the new answer. These are all mathematical skills that you are marked on. Showing you're working out like this and analyzing your own work, you are marked on that. So if you get that opportunity, do not rub it out.